Welcome to an introduction to the static routing and next hop routing functionality of the Ecessa solutions. The purpose of this video is to describe the various static route and next hop route configuration options. If you have specific questions about setting up a particular route, I'd encourage you to reach out to our support staff who are always happy to be of service. To begin, let's define static routes and why they might be utilized. By default, the PowerLink series of appliances will intelligently load balance outbound traffic based on the speeds of the multiple WAN connections, combined with a view of the amount of traffic currently going over each connection, or the utilization, determining which connection has the most available resources at that moment. However, there are situations where you might want or need to overrule that behavior. As a few examples, perhaps a remote site requires, for security reasons, the connection to originate from a specific WAN or source IP address. Ideally, long-term, they would be contacted to add the other WAN connections as valid for load balancing or failover purposes, but until that's set up on the remote end, a static route can make sure that those connection attempts meet their criteria. Another example might be if one connection is superior in some way, either having a significantly greater amount of bandwidth associated with it, or perhaps a noticeably lower latency. In that scenario, it might be preferable to send particular types of traffic out that connection. You might prefer to send real-time traffic like voice or video over the lower latency connection, for example. Finally, you may be dealing with metered connections, so perhaps you want to limit traffic on that connection while still leaving it available as an option for failover. There are other uses for static routes, but those are among the most common. So, we configure static routes to overrule the default load balancing behavior for outbound traffic when necessary. Note that when we're talking about static routes, we're dealing with outbound sessions, sessions originating behind or from the Ecessa device going out. Inbound sessions will always go back out the connection they came in on and would not be subject to static routes. The equivalent of static routes for inbound traffic would be handled by the authoritative DNS functionality, which will be covered in a separate discussion. So, taking a look at the configuration options, note that there are 5 categories of static routes: high priority entries, internal route entries, medium priority entries, WAN routing, and low priority. Note that the routes are displayed in the priority order as viewed on this page, with highest priority near the top of the page and low priority at the bottom. High priority routes are configurable and create a route before all internal routing. This is potentially dangerous as it can block access to the device or cause unintended results. The internal routing section can be viewed to see what routes are set up for other features but are not configurable. Medium priority routes are configurable and are placed before the WAN routing. As for WAN routing, these are routes that are created to ensure that traffic stays on the WAN it's supposed to, providing session persistency, etc. These are not configurable and are noted here simply to easily identify where they fall in priority. Low priority routes are configurable and are generally the recommended default static route type. All configurable entries can be identified by source subnet, destination subnet, protocol, source port, or destination port, or a combination of these criteria. The route is where you would enter the desired WAN or WANs for the specified traffic. This can be a specific IP or a host name, or an alias. You can enter additional WANs by pressing the plus button, for example if you wanted the specified traffic to route over a group of WANs, and can set the priority levels as well. At this point, we'll take a look at some of the behavioral options for static routes. As you can see from this drop-down list, there are 4 types of behavior you can select. The first option is Failback. This is the most commonly utilized behavior and is what is chosen by default. Essentially, Failback means that the traffic defined by the route will go out the connection you've specified. However, if that connection were to go down, the traffic would fail over to the next available connection. If the preferred connection comes back up, Then beginning with the next session, the routing will once again begin sending traffic out that preferred connection, failing the traffic back to that WAN. Note that it will not bump back connections that have already been established on another connection during the outage. Normally a good thing, as that could be disruptive to the session. The exception to this behavior is if you utilize the VPN checkbox here for site-to-site IPsec VPNs. If the VPN checkbox is checked, the VPN will in fact bump the VPN back to the preferred connection. As a site-to-site VPN is typically an always-on connection and already established session, without checking that checkbox, the VPN would stay on the failover connection until something triggered it to bump back. The next option, failover, is similar to failback in that the traffic defined by the static route will go out the connection you've specified, and if that connection were to go down, the traffic would fail over to the next available connection. The difference, however, is that if the original preferred line were to come back up, the traffic would not bother to fail back beginning with the next session. The traffic would keep plugging along on the connection the traffic had failed over to, including future sessions. This type of route is useful if you want the traffic to travel over a single connection but don't especially care which one. Next we have fixed, which is fairly self-explanatory. Traffic defined by the static route will always go out the connection specified. If that connection goes down, the traffic simply wouldn't go out. There's no failover with a fixed static route. Finally, we have hostname failback. This could be used if the source WAN for the static route is defined by a DNS hostname rather than a specific IP address. Hostnames for static routes would typically utilize our authoritative DNS functionality to define the multiple addresses, typically based on the multiple WANs, that the hostname would resolve to. If the first address in the host record fails and then returns to service, it will revert back to using the first address. Under each rule, there's also an advanced option. Under this option, we can identify the path. The user-defined paths are configured through the link at the top of the static route page. This function identifies specific testing destinations. It's more specific and accurate than the general WAN testing, and helps when there are routing issues within a particular ISP to a particular destination. Useful for scenarios where the WAN test points may be reachable and therefore the WAN is seen as up, but a particular service is not reachable over that particular WAN. You can identify the service's destination here, as well as the testing parameters, and then apply this user-defined path to a particular static route. Going back to the main static route page, you see that we can enter the specific name of the user-defined path under any route. Next, we'll take a look at next hop route configuration. Next hop routes can be accessed under the Routing NAT section as well. Next hop routes are a simple way to forward traffic destined to unknown networks to particular IP addresses. Note you'll need to make sure that the feature is enabled via the checkbox at the top. Configuration of the routes is fairly simple. You begin by setting a source network. This can be an alias, a specific IP address, a network with a subnet mask, or left blank to indicate any. The destination network field is similar. It can be configured with those options as well. The next hop IP is where you would enter the IP address to which to forward the traffic matching the defined source and/or destination. The routed via area allows you to select either a private LAN or a public WAN over which we would not NAT or translate the addresses. Note that you can also disable any individually configured next hop route by the disabled checkbox. As always, when you're finished, be sure to save your configurations and replicate to the idle device if one is present. There we have it, static route and next hop route configuration. For additional information, please don't hesitate to contact our support department, who are always happy to assist.